ఓకే ఓకే ఓకే. అయ్యో రామ్మ, నేనేం చేశాను అంటే 7 మంది కాల్ చేస్తారు మా అమ్మఒడి, అందుకోసం నీకు టైం చెప్పి పోస్ట్పోన్ చేస్తానండి నేను. అయ్యయ్యో మళ్ళీ అది చేస్తారండి, నాది పోస్ట్పోన్ చేస్తాను వర్క్, నేను మళ్ళీ చేస్తాను. ఓకే ఓకే, మొబైల్లో చెప్తారా? అవును, డిజిటల్ మోడల్ అంతా చెప్పింటారా?
Participant, please mute. Thank you to all. Now I am requesting our second group leader, KVS Prasad sir, to present today's yesterday's repeat.
Sir, Jilani madam
Sir,
is
welcome to
Nasima madam. Sir, you are saying something, sir. One second, madam. Sir, he is saying something, madam. Pramay sir.
Welcome to our principal, sir. Kumar sir.
Sir.
Today's session.
Sir, good morning, sir. Welcome to the principal, sir, Brahmaya, sir, and other resource persons like Satyana, sir, and Kumar Swami, sir. I welcome to the program, sir. The third day is going on, and this is the presentation of the yesterday's program. Mrs. Nasima is going to present this. Thank you also. Nasima, madam.
A very good morning. To the course director, Principal KV, and very good morning to all the participants. I am Nasima Jilani of Guru presenting a report of yesterday's happenings. Our day started at 10 a.m. with a prayer, followed by a report on the previous day's happenings. Later, our workshop director, Mr. Shravan Kumar, presented the day's program to be taken up by resource persons, Mr. Purushottam and Mr. Rasul. He said, to achieve learning outcomes, many resources are to be used. One such important resource is multimedia resource. Mr. Purushottam, sir, the resource person, threw light on these resources broadly divided under two headings, FOSS and OER, where OER is like a library. FOSS is all about the free softwares which can be effectively used by teachers. Many apps like Busy and Maths Tool, Maths PHET Interactive Stimulation, GeoGebra, Robo Compass, GraspableMaths.com, KahootQuiz.com, etc. were thoroughly explained in a very convincing manner. Discussions on apps for evaluation, games, and screen recording made the day fruitful. We broke for teamwork at 11:30 a.m. The day concluded with the presentations on multimedia resources by all groups at 5:30 p.m. It was a great day, definitely broadening our horizon about resources. The objective of the day's program was achieved. Thank you.
Thank you, madam. Sir, over to you, sir. Brahmaya, sir.
Thank you, madam. Thank you very much. Thank you very much for your presentation. Kumar sir posted a message in that our problem in his area. So I am requesting Satyanarayana sir and sir, if you are there, please start. Satyanarayana sir.
Yes, sir. Actually, Saru has to start session, but the power is not there in the TV. So I am starting this, sir. Now I'm starting this program. Good morning to course director and coordinator and all the participants. I am V.V. Satyanarayana, TGT Maths from KV Kurnool, Hyderabad region. And today topic is mass modeling. So we are going to learn about mass modeling. Though we have mass modeling at the end of the textbooks for 9th, 10th and 11th classes, but we are not that much concentrate on them because it's not in our syllabus. But nowadays, mass modeling is very, very important. It's playing very important role. It is being played, but we are not concentrated on it. Every field in industries and pharmacy and see about disaster management, everywhere mass modeling is taking place. But we don't know that. But here in this session, we are going to learn a little bit about the mass modeling. So that you can concentrate while we teaching in our classes. Okay. Then I'm going to present. Please confirm me whether my presentation is visible or not. Is it visible, sir?
Yes, sir.
Yes, sir.
Yes, sir.
Visible. I think audible to you.
VVSN, sir, visible.
Oh, sir. Good morning, sir.
Good morning.
Thanks. Mass modeling, mathematical modeling, competency based learning in mathematics. Is it sir?
I request everyone to please mute your mic.
Log in with one either phone or laptop.
I think unmute. Let's mute them so that I can my voice.
Yeah, now it is okay.
Okay. This is our workshop is competency based learning in mathematics. And Mr. Kumar Swami and myself is presenting this session. Mass modeling. We'll go to that mass modeling. Mathematical modeling is an attempt to study some part or form of the real life problem in mathematical terms. So whatever the real situation we are taking, that real life problem we are studying in mathematical way, mathematical form. So before that, we are going to learn the mathematical model. There is a slight difference between the mathematical model and mathematical modeling. Let us see what is mathematical model. A mathematical model is a mathematical relation that describes some real life situations. So what we do here, mathematical model, we take some situation, for example, areas. Let us say that cost price and profit and loss. So first of all, we study what are the variables in that. In that variables, how they are related. When the relation we say is a proportional or direct proportional or inverse proportional, that we'll take it first then. And we'll frame a relationship. And after framing relationship, then we find out the total of formula for that. And this formula, by defining the variables, is it reliable or it can be solved any real life problems? We go like that. For example, area of circle, if you take it. So then area of circle is pi r square. We'll deduce the formula. This is there in the 7th class also. And from that, finding the area of the formula, then we'll solve the real life problems straight away. This is a conventional method which we are following. But what is the difference between mass modeling? So mass modeling is a slight difference. The process of translation of real life problem into a mathematical form can give you a better representation and a solution of certain problems. The process of translation is called mathematical modeling. What we do in that, we'll get reverse in the way. We'll take the problem, a real life problem, that is to be solved. While to solve the problem, first of all, we'll study the problem properly, and we'll have the assumptions. So what is given, what to find out, we'll take assumptions. After assumptions, then we'll find out what are the parameters, what are the factors in that one to be given and to be found. So these factors, how they are related, then we'll go for mass model. So which mathematical model is rightly applicable to solve this one, to solve these that's called variables. So then we'll select the mathematical model for that appropriate problem, that is that real situation. And then what do we do? Then we'll solve the problem. After solving the problem, then we see that evaluation will do it. So what result we got it, and we will interpret it. We'll interpret it and we'll evaluate it. How far this solution is applicable to the real situation. So then we'll see the reliability. Is this solution which you have found, is it specific to this problem only, or we can extend to any such problems, or this is reliable, or this can be refined? That and all we'll see in this session. So in mathematical modeling, we take a real world problem and write it as an equivalent mathematical problem. That is mathematical model. We then solve the mathematical problem and then interpret its solution in terms of real world problem. After this, we see what extent the solution is valid in the context of the real world problem. I think clear to you. And then I think I'm clear to you that what difference between the mathematical model and mathematical modeling. Okay, next. We'll see that where is the situation, we'll see that where mathematical model is very important. Everywhere it's important, but some I will show you. Finding the width and depth of a river at unreachable place is the one. And then estimating the mass. Estimation will do it. Estimation is you can use any models also. Mathematical models you can use. So estimating the mass of the Earth and other planets, different ways you can do it, this one, estimation also. And estimating the distance between the Earth and any other planets, so different scientists will have different methods. And predicting also, predicting of population of the city after 10 years. So predicting, estimation, they go very near to the values. May not exact, but very near to that. So estimation, predicting, and then estimating the number of leaves in a tree is also number of leaves in a tree, number of trees in a forest. That is how we will estimate them. A number of fish in a pond. So everything will by estimation. Then we will use the mathematical modeling in the sense. And estimating the number of fish, and that's what I told you, fishes in a pond. A slight difference here, I would like to say the grammatical. Fishes is a plural form of fish. Actually, fish plural form is fish only. But if you have one type of fish, we'll call it as fish as a plural form. But there are different types of fishes. Then we'll say that you can use the word fishes in a pond. Okay, that is clear to you. And then estimating the temperature on the sun's surface, where we know we cannot go directly and find out physically, but by mass modeling, we have the using the mass model, we can find out the temperature of the surface, which we cannot reach them. That's all. First, I told you, unreachable places. Unreachable places also we can, by using mass modeling, we can estimate the values which we want them. So this is one thing. And what is the advantage of mathematical modeling? I think by the time you can understand it also. So what advantage? Let me tell some of the advantages of mathematical modeling. So the advantages of mathematical modeling are many, but some I will show you. Models exactly represent the real problem situation. So the real problem situation only will take it. Then we go for mass model and we'll solve it. So mathematical modeling will be applicable to real problem situations. That is clear to you. And models help managers to take decisions faster and more accurately. So this is happening in the industries and working in a shipyard and see that airport. So these managers, they will take decisions faster and more accurately. Okay, so different mass modeling, they will go for the different trials also. They will take decisions and they will go faster and they will find the exact solution for that. Next is, they typically offer convenience and cost advantage over the other means of obtaining the required information on reality. This is the field for the economics, like trading, and see that exports, imports, everything here in comes that the cost, then minimum sales price, how to fix and all this and all, you can do a mathematical model. So every field mathematical modeling works out. And large and complex problems can be solved with this. That's what I'm saying. Large and complex problems also, they will go step by step math modeling and they will solve the problem. For each one, they will take a small stepwise math modeling. Everywhere they follow the mathematical modeling, stepwise they follow and they solve large and complex problems. Models act as communicators to others by providing information and impact in changing conditions. Like disaster management, you will see that. So once they already experienced, and these models, they can they use, other people use, and for the information and for any changing condition, they will use again here, and they will change the mass modeling by their convenience also. So this one research I have done mass modeling one way, and that same thing is used by changing the variables according to the conditions. You will see. Okay, right? And see, these are some of the advantages of mathematical modeling. And different types of models. What models are there? See, different types of models are there. You'll see that. Physical model. What are the physical models? Physical model is a smaller or larger physical copy. It is a physical copy. Like that, if you see that globe, it is a physical model of the Earth. If you take about that solar model, they are big in size, but you cannot show. So we take it, a copy we take it, and the small balls we can represent the solar model. This is the physical model. So you can understand that very clearly what is actual when compared to the model. And very small things are there, like molecule models, and those cannot be seen. So then we can study by using the making the molecule model big in size, so you can understand. So this is the physical model, which you know that we are using that in the class also. And a conceptual model. In conceptual model, this is based on that concept and then ideas also. It is a model, a representation of a system. That we use there, we use the concepts and ideas to form. Any representation is there, then for any representation, then we will have the ideas and concept, and these will be represent that concepts. Okay, it is used in across many fields, ranging from these models are used from science to socioeconomics, and from that to software development, So this can be extended. Conceptual models are extended for one field to other field. Okay, right? And the next scientific model. Scientific models, we know very well scientific models. Scientific models are representation of objects or systems or events also. And these are used as tools for understanding the natural world. Okay. The models sometimes use familiar, we use the models with familiar objects and we represent or we study the unfamiliar things. So models can be visualized or picture we can do. We can have the picture in our mind. So something that is difficult to see, to understand it. So these models can help scientists because they help the scientists communicate their ideas, understand the process, and make predictions. So these scientific models in our school level also, we are using the scientific models, and to show the procedures, to understand the process, we are being used these physical models for the scientific models and the learning models. So these learning models are somewhat research type. Okay, and then learning models are critical to innovations in education, what it may be, because they communicate new ideas about learning and in visual and compelling ways. So learning models are somewhat cognitive, and then there are application of this. From that learning models, they can innovate things. They can do new things. Innovation will be taken place by learning models. Okay, and then digital models. Digital models. Already, I think you are experienced about digital models because in the last session, yesterday, I think we are using many digital models. Okay, so digital models we are using what is GeoGebra and FET we are using Scratch. I think Sir might have told, Mr. Vivekam Sir might have told about this one digital models, and clearly these models will be taken up by Mr. Kumar Swamy Sir regarding this digital models. And then next pedagogical model, which is related to us in the class, how we use the pedagogical models. Okay, the pedagogical models are cognitive. They are cognitive models and theoretically constructs derived from learning theory. Whatever theory we are learning, then we construct it pedagogical models. So another way, one teaching is one of the part among them. So whatever the information we have learned, okay, but then we can implement this information by using the pedagogical models. So or you can use pedagogical models and we can elicit the what you have concepts and also theorems. Sometimes any new which is mentioned in our curriculum. So whatever the curriculum is mentioned then we can prepare pedagogical model on the basis of that. But because of this one, then it is restricted to that. So some class up to 6 to 8, some restriction will be there. So you can prepare that because according to a curriculum model, the pedagogical models for the different syllabus, how different models can be prepared. Okay, and of course we can use these models for the lower, but lower grade and higher grade depending upon the demand of the that is the concepts, the demand of the learning outcomes in the given syllabus. Okay, right. And mental models. Mental models, I would like to say that I think we are being, and right from the beginning, we are using the many indoor games are there. I can see the indoor games. The mental models are there, and we can use the chess is the one among them. So these are chess is the one among them. It's innovated before after using the chess. Before that, how it is someone's idea thought process. Okay, about this one, and that idea is turned into that idea turns into a model. So one process, you can say the games. So the games comes under the mental models. This specific thought process used to examine the problem. Suppose any new thought is come, then that is implemented in the process of the mental models. Okay, so mental models maybe that in oral also you can have mental models, and then we have to use the models and where we apply our knowledge to play or to handle the game. So these mental models are many are there. You can use that because simply I told about some of the like chess I told you, and you see that what you call it in Hindi, I don't know about the Telugu, Bharatata is there. So these games will be depend upon this one. So many games are there, many models are there. You can use it, but these are made. How they are made by the one's thought that the thoughts are processed to make this mental models. Okay, and then next is modeling phenomena. Modeling phenomena. This I will. I think in the next slides it will be understanding that what is the phenomenon modeling. Okay, then you understand it next. I will explain the next slide. Next is modeling real world. This is actually our syllabus, our part of the session. So modeling is a real world, and the ability to model natural and human phenomena. Where is happening the actual things? I mean, human phenomena is key to understand the physical, biological, and human environment. So they have been a broadness of this real world. What is the real world? Where the problems are there, we need to understand about this. That we are dealing with that. And for example, you can say that what is the real world? What the problems are there generally? Can anybody say about that? What is the real world problem? Can you one or two participants can you say that where the real world problems are arising? May I ask? Is audible to you all?
Yes, sir. We are able to hear.
Yes, now can you suggest me some real world problem where the field is enough?
Sir, cybercrime.
Cybercrime, very good, sir. Just one or two or three. Yes. Sir.
Even present pandemic, sir.
Yes, sir.
Economy.
Sir. Pandemic, yes.
Economy.
Sir, very nice, sir. Very nice, madam. Then I will add some more. Population growth. Just someone told about this one pandemic. This is the progression. And in the city, I think Hyderabad city, the traffic flows. And one more thing is very useful. Every day we are living in the news about climate predictions. So these are some of the real world problems where we are.
Effect of pollution, sir. Effect of pollution.
Yes, sir. Very good, sir. That's the pollution. Everywhere, sir. Everywhere mass modeling taking place, but because we don't know that it mass modeling, they are solving problems using mass modeling. We don't know that much. So now I think it's clear to you where this mass modeling is applicable, how this is there. And next we'll learn it according to our syllabus, 6 to 8 syllabus we are taking, and one problem we have taken from the trigonometry also. Then we'll see that how they are related. So because if you take the known situation to us, if you know study about that one, then we can apply to the other fields. So let me go to the next one. Real world problems and mathematical model. So just sir mentioned about this one. COVID-19. In COVID-19, the many parts of things are there where is mass modeling is applicable. Migrant workers, inflation, budget, health, immunity, economy. In this one, at least COVID-19 only, we are seeing all these fields are affected, and they have solved the problems by using mathematical model. And about the health and immunity, they have told that use mask and maintain distance. So this and all they studied about and they have given, because we know only solutions only, but how they have processed we don't know. So this way, by using mathematical model, they process everything. Okay, that is the main role is playing there. And then next is demographic nature of COVID-19. So this is the demographic means here they have taken the fraction of people, that is population. There is one part of population where they are under age, they have studied about that. Under gender, they have studied about race, culture, communities, states, and economic classes, how they are affected. And what is the affected, then how they are treated, and what is the treatment going to take place. Everything they studied. So demography means some part of the people who are suffering, they have taken the study about this one by using the mathematical model. And then, so what they do actually in the mass model now, they will identify the problem. Problem will be given to they will identify the problem, what is going on there. So they will identify the problem is in a real situation, And after identifying the problem, they define the factors, what are affecting. So then they will make assumptions. They'll make assumptions and they will give the variables to that one, and then they construct a math model to that. Means it is a formula, they can say formula, involving all the variables, all the other factors. Then from that they will collect observations. So they will collect the data from that. So they will collect the data and they will then see that how this data, this mathematical model is applicable to this data, and they find solution and see how far it is. Then they will see for that reliability of this process or this model is rightly appropriate to this study the problem. They do that. So total entire thing is called mass modeling. This process, entire process is called mass modeling. Right, sir? Next. This is the one. The COVID disease centers they have studied about this mass modeling, and this is one of the things. One of the picture I'm showing you simply here, so that how they study about the that is that is fraction of people, how they study about this one. These people which are affected, how to maintain their loss, they study about this one. Okay, next is process of mathematical modeling. Just we are going to the process. So what is the mathematical modeling? Sir, is it audible to you? One second, I'm checking myself.
It's okay,
Yes,
sir.
sir, we can hear you.
We can
Yes,
hear
sir,
you.
yes, sir.
Right. So how the is a real life problem. When you have a real life problem, then what you have to do is understand the problem. While you have the problem, understand is studying the problem properly, and what are the given and what to be find. Then we may simplify it. The problem is simplified. Means that's the phrase we can simplify the problem. So sometimes no real life problem. The problem you can simplify it. One problem we have one mass model, other problem we have other model also. So that's why you have to simplify it. And one mathematical modeling, you have different. You can use different types of mass modeling also. Okay, and then describe the problem in mathematical terms. This is the next step they are doing. So they will study about this one. They will study what are the factors are there, and then they are represented by the variables and how they are related. They study, and then they will find out the mathematical formula for this. Then they solve the problem. They solve the problem. So they will solve the problem, and by using the mathematical model, they will solve the problem. They will find a solution. They will find answers. Then what they do, they interpret the solution in the real life situations. So these answers they study. What are the answers you got it? They study about this one. Is it applicable to the real situation? Is it giving any sense to the real life problem? They study like that. And then if the solution captures the real life situation, very good. So if our solutions are interpreted, then they will see that this solution is applicable or rightly that is applicable to the real life problem. Once this is real life problem is applicable, then they will say that yes, model is suitable to that. So then they will confine to that. Oh yes, this model is suitable for to solve the real life problem. In case after finding the mass modeling, it is not solving it is not reaching the problem, reaching the solution of the real life problem. What they do, then they will go back. They will change the assumptions now. After changing the assumptions, then what happens? The factors will change, variables will change. Then what they do? Again, they go back to the situation, describe the problems in mathematical terms. So they go process. So this is the process of how the mathematical model works out. And then next, examples of mathematics modeling. So what examples we see in mathematics modeling? So first is estimation of fishes in a lake. This is one of the methods only, not all the methods. There are different methods are there, but to understand very easily, I'm taking very simple method so that you can understand very well about this. There are some sophisticated methods are there how to find the population of fishes in a lake. Okay, this is how to do this. We'll see. So we understand the problem. Our problem is that we are estimating fishes in a lake. So that we are doing here. So what do we do? This is the problem study. Suppose our problem is to estimate the number of fishes in a lake. It is not possible to capture each of these fishes and count them. You cannot do that. We could possibly capture a sample and from it try and estimate the total number of fishes in the lake. So we'll do estimation here. Some part of the area in the pond we will do the experimentation. That is mass modeling will do it. And that we will extend to the whole pond. Okay. But how it is going on, let us see. I think a problem is clear to you. Very simple, estimation of fishes in the lake. So this is a problem happening here, that is estimation of population in a certain area, estimation of population of trees in a forest, estimation of leaves for a tree, everything will go in this way. And there are many methods are there, method modeling is there, but I will take it a small method how to do this, so that you can understand very easily. So this is the pond where different types of fish are there. Then we are going about finding the population of this fish. So now we are going to about describe this this condition and we formulate it also. Let us see. Let us take a sample of 20 fishes. So, but that means that first capture, we catch 20 fishes from the lake and we mark them. We mark them different way. They mark the fishes. Sometimes they do which is not dissolved in water. Sometimes they use the marks. Sometimes they do rubber band. They show some what you call metallic also. They use it. So they will mark the fishes in this way, and then release them in the same lake, so as to mix with the remaining fishes. First of all, take the 20 fishes and you mark them. Then again, you leave them in the lake and wait for some time, so it all will mingle and randomly they go in the pond. Then next, we then take another sample. This is second capture. In second capture, we will take, let us say, this is only numerical convention only I have taken here. So let us take another sample of 50. 50 fish will catch it. Suppose we make it out of 50 fish, that is exactly means 50 exactly will take it. The remaining will see this. And from the mixed population. So in 50 fish, what will happen here? There are normal fish and marked fish also there. So because second capture, no, they all are randomly moving in the pond. So when you take one part of from there, we are taking the 50 fish, and here we have the marked one, unmarked one also there. So then we will count it how many marked are there. So we gather our data and analyze it. So we'll count them. So now this is that is the assumptions we are taking. So the first one is called a method description or assumptions for this one. Next will be the variables to this one, and we'll find out the mathematical solution. So suppose in the second sample, second capture, an example in step 2, 5 fishes are marked. So 5 fishes are marked out of 50. Out of 50. So on simplification becomes 1/10. So 1/10 of the population is marked. So 1/10 of what population? 1/10 of the total population of the fish in the pond is marked, right? And then if this is typical of the whole population, the same thing will be there for whole population. Then 1/10 of the population is equal to 20. Okay, right? Because 20 fishes out of 20, okay, 20 fishes are marked. So 1/10 of the population, okay, is equal to 20. Because 20 fishes are marked. 1/10 is the second capture we have taken. 1/10 of the fish are marked out of 20. So 1/10 of total population is equal to 20. And then, so now the whole population is equal to, you can solve a very simple fraction. The population is equal to 20 into a 10/1, that is equal to 200. So this is the way we find the population of fish in the pond. Now, after finding the solution, we interpret the solution. So the solution obtained in the previous step is now looked at. We'll see it. So we should write down interpretation solution. We should write the answer here and we'll discuss it. In the context of the real life situation that we had started with the step 1. So for instance, our solution in the problem step 3 gives the population of fishes in E as 200. That is one. And then validity of the model. So how far the modeling is over for us. Now we are seeing the validity. we go back to the original situation and see the results of the mathematical work makes sense. It gives any sense or not. If so, we use the model until new information becomes available or assumption changes. If it is not satisfied, that we can change this. So here in this modeling, so anybody can suggest here we have taken only one trial only. But if you have the refinement, if you go to refinement of this model, and we can go for number of trials. So, for example, if you one trial is there you won't get a marked fish. What to do? You won't get a marked fish. Then what to do? What to do? Anybody can suggest what to do?
Repeat, sir, please.
Hello, sir.
If second capture, we'll get the fishes. In the fishes, there is no marked fish. Then what to do?
We capture again, sir.
Yes, that's right. So we drop the trial. So suppose if you get it, of course, will not happen. Suppose you get all the fishes are marked. That also we drop it. So in middle we will take it. Suppose it not happen because if it happens, what to do? So we can drop it, and then to have the more estimation value very near to the population, what can be refined this model? How can you refine this model? So one trial I have taken here. So then what we can refine this model so that we can get a nearly exact value of the population of the fishes. Anybody can suggest?
We have to do the same thing more number of times, sir.
Very good, madam. Very good, madam. I'm not able to see you, but very good, because we have a number of trials. Number of trials if we take it, that's nice. And number of tests we can take it. Then how to get this? How to get the one value from that number of trials? What can be done?
Can we take average of those?
Yes, madam. Arithmetic mean. Yes, correct, madam.
Average.
Yes. Remember that is arithmetic mean can be found. So we can use another mathematical model, that arithmetic mean also can be used here. So it is very close to that, very close to the population of the fishes. Very nice, madam. Very nicely catch the point. And then examples of the mathematical modeling. Let us see. One more example we have seen. We have seen about that the real life situation. We have seen that, and one more situation we are seeing. Suppose Ajay has invested 15,000 rupees at 8% simple interest per year. So what is the amount invested is 15,000. Very clear, which we do. That is conventional method we are doing. But the problem is, see, with the return from the investment, he wants to buy a washing machine that costs 19,000 rupees. For what period should he invest 15,000 so that he has enough money to buy a washing machine? So this is the problem. Actually, problem is the textbook problem is there, but this is a refined that one. This is extended to a real situation. Problems are there in your textbook also from degree 6 to 8 also. But this problem we have taken, and this is extended to the real life problem. This model one we have to do. I think as an individual work and group work, this type of also can be done. So then I will proceed, madam. Yes, I proceeded. So the washing machine. So here we know the principal and the rate of interest. We know two factors only. That is 15,000. That is the principal, and 8% rate of interest. The interest is the amount Sudhir needs to addition to the 15,000 to buy the washing machine. So now we are interested to find out how many years he has to invest the 15,000 rupees so that he can purchase the washing machine which costs 19,000 rupees. I think clear. Problem is clear. Probably understand. This is the understanding problem. And mathematical description will see that. We'll go by simple interest only to understand better. So the formula, this is a mathematical model we are using here. The formula for simple interest is I is equal to P into R into T by 100. So this can be taken. That is the interest is related to the principal, directly proportional to principal, and interest is directly proportional to rate of interest, and interest is directly proportional to time period. So by combining this one, we get a formula. What I'm saying here, the relation first we have to see, because this is known situation we know very well. But if you know unknown situations also we have to study. So suppose like this is unknown situation, then I can tell you, and interest is directly proportional to principal. That can be studied. And interest is directly proportional to rate of interest. That can be studied. And interest is directly proportional to a time period. After coming this, we'll form, then we make a formula. I is equal to P into R into D by Q. So after making this mass model, then what to do? And we should describe it, what is P, what is T, what is R, because variables should be described it. Okay, right? This is called description. And then what values we are having, then we have to give. That is the P is equal to 15,000. And then that is R is equal to here 8%. So the money required to Sudhi for buying washing machine is 19,000. This is the amount. See, amount should be 19,000. So the interest be earned. The difference between the what do you call this amount and the principal is clearly 4,000 rupees. So then the number which you have to find out is by the time period we don't know. That we have to give one more variable to this T, and then formula is there, and apply the formula and substitute the values. Then we'll get their relation. So we have, that is I is equal to 1200 into T on simplification gives the relationship between the number of years and interest. Okay. Then 15,000 is invested at annual interest rate of 8%. Then what time, how many years it takes place so that it is going to be amount as 19,000 rupees. So we have to find the period in which the interest earned is 4,000. So can you, I think here is, our interest has come now for us, 4,000 interest. So substitute the value 4,000 here. And then T only unknown factor, T can be found. T can be found as, that is,
4 years.
Yes. That will be, I think, is it clear to you? That is 4,000 divided by 1,200. You'll see that answer will be.
Yes,
then
yes.
after that, solving the
Yes.
mathematical problem. So
It is
the time,
3 years, sir.
sir, may yes, sir. Anybody wants? Anyone wants to say? Please unmute. Please mute the mic, madam. Then T is equal to 4,000 by 400. That comes to yes 3 1 by 3. That means 3 years and 4 months. So this is the solving mathematical problem. So problem is solved and time has come. And now we're interpreting solution. What solution we got it here? That is, he has to wait. He has to wait 3 years and 4 months to purchase the washing machine. Okay, this is the interpreting the solution. So this is the answer for this question. And then validating the model. So we go back to the original situation and see the results of the mathematical work make sense. If so, we use the model until new information becomes available or assumptions change. Okay, in validating a model, sometimes there is a practical problems also come. How we are calculated for the in the future the 3 years 4 months things we are going to purchase. That way this is calculated and a model is made. And suppose there is a lot of changes may take place. The value of the washing machine may come down or may rise. This is the practical problem for that. So then what extent? Then how far is evaluating? So it is evaluating up to when the rate of washing machine is constant. And this modeling is applicable to this one. Okay. I think these two examples you have seen that it is small examples I have taken to you to understand readily. Then we have taken while doing this work, maths modeling, while doing assessment, and it is a group work. You have to write down these steps also, and write the steps also, so that you can understand it very clearly. Then particular expectations. So what you are expecting from this?
So may I ask you one question now?
Yes, madam.
So how this sums are different from the statement sums what we do, like in general textbook may whatever statement application sums what we do, every sum is a mathematical model only, no?
Yes,
How it
madam,
is?
yes, madam. And actually one textbook, what we do know, I told in the beginning, we are using the mass model we use, not modeling. Mass model means we learn the formula and we use the formula to solve the problem. Like just now I told about the we are not taking the situation which already given situation, but already the students learned, or we teach them to mass model, we teach them. Means formula will teach them. We'll apply the formula in the problem and we solve it. This is one way. It is given already. It is conventional. It is conventional. What you are doing is conventional. But in mass modeling is a real situation. It is a new situation. There we go and we find out and we solve it. So current problems also will be there. So this is some of the problems are expected and they have given to us. One way is going conventional method, but the other way is going that the mass modeling, like a fish problem. I told me I take the difference also I have shown to you. The fish problem is there that we are not so exposed to that. Only those people, the aquaculture people, they know the problem. They have the methods of doing. So that is really this is a different field which we are not exposed to that. So now while do mass model also, don't take from the textbooks. So we go to the out of textbook. Go to out of textbook and see situations where are they and do the modeling. So then we can understand very easily. So because how people are solving the problems by using the mass modeling. I think I'm clear, madam.
Maybe sir, some more examples I may understand better.
No, I told my, for example, you see that area. I will tell
all the statement problems, whatever we come across, mathematics, not only textbook, even the other real life situations, any situation is there, we do apply our mathematical techniques and we do it. So are we not, they all come under mathematical modeling only, no?
Yes,
exactly. Though it is conventional, we apply mathematical modeling only.
Yeah. Mass modeling will apply that and we will solve the problem. That's it, mass modeling. The mass model you are taking. In the modeling means situation you are taking, we will use the math models. Sometimes what we study in the syllabus, these models may not be used also.
No, sir. Actually, to give the clarity in the concept, we give them a situation.
Madam, let me clear. See, we are doing in our class also mathematics modeling, but we don't know that we are doing because we don't know the steps of the mathematical modeling. So that steps we are following by doing real life situation also. For example, height and distance questions we are solving, so we are following the mathematical modeling only, but we don't know we are not aware with the steps of that process of mathematical modeling, but we are doing.
So the exactly, so whatever we are doing our mathematical modeling only, nothing different than that. The headings are different.
Yes, madam. These are the
process, madam. This process actually.
Process is same, sir. Actually, stepwise, what the steps you have shown, we go in that way only, na?
Yes, madam.
To solve any situation. Actually, the statement problems are nothing but the situations only.
Yeah.
Real life situations only. Even in the textbook also.
Madam. See,
yes, sir.
Some teachers used to do that even for solving word problems, they will show that what is given in formula they will do and they will solve. So that is conventional method. But when we are going through this process, and we are doing also, many are doing also. So that is mathematical modeling.
Okay, sir. Maybe.
Only thing is that the modeling.
Actually, a slight difference is there. A slight difference, not much. Slight difference is there. Madam, if you take the problem given in textbook, you can refine it, the problem, solution, you refine it, then it comes to mass modeling. Or because real situation, we add to that. So,
yes, sir.
If you add a real situation to that one, the same problem can be taken as mass modeling, but add some more questions to that one for the real situation to solve it. For example, madam, you take the pond. For example, pond is there. Around the pond, it's a circle pond is there. Then suppose that is the distance is taken. That is by walking, if you take the measure the distance, then what is the diameter of the pond? From that we can find out the diameter of the pond. So that is a direct problem. Direct problem is there. We'll find the what you call perimeter. That is 2 pi r circumference, and from that we find the r, and we find the distance. That is direct. So if you add to that some more adding that one, suppose you want to construct a bridge. What is the highest length of the bridge can be constructed? What is the cost of this one? What is the railing will be taken place? So if you add to that problem, because that is a real situation where they have to fix it. So that we add it, then becomes when after follow all the steps, then we can get it becomes a mass model. So because we are following the process of this one step by step.
Sir, and one more thing, real life situations when we are relating, they should be very familiar to the every child. Like see pond, I don't know how many they can do the fishing and all. see, sometimes they correlate in that way also, na? If we give any example, like if they visit a market and if they pick up
Yes.
the things and all, it may happen in their day-to-day life. But
Yes, madam.
situations also we should relate according to their flexibility and feasibility.
Not only that,
Only
madam.
they can correlate with the situation. Otherwise, I
Madam,
think,
let
yes,
me,
sir. Yes, sir.
madam,
Yes,
see,
sir.
child will not buy the washing machine, but we have to give that example also, which
They may
which will
go
come
and they can observe that, na sir. See, they may go.
Madam, see, all 100% we can't assure that the child will experience in his real life situation. We have to form some real life situation which occurs in all day-to-day life, not only the particular child.
Madam, and only the experience they expose from the, not only from that real life, here life which the student is exposed, but beyond that also we can go. For example, pandemic, how it is going on with COVID-19 and disaster management. The boy cannot see the disaster management, but how this mathematically we are estimating or predicting everything. This can be learned. This is the one of the mathematical skills he is going to learn it. And we can, if you take the situations in the different fields, which he is not directly is seeing, but you understand that mass modeling is being applied in all the fields. You are exposing the student to understand this concept where mass modeling is taking place. So one type of research you can say that. So how the mathematics is applied, because he is broad mainly, you understand it. For mass only, not from only confined textbook and formulas only. There is a field where that's mass modeling, that mathematics is applied and to solve the problems. We can make them, we can make it to broad-minded also. Okay, madam?
Okay, sir. Thank you very much, sir. Kumar sir.
Oh, madam. Welcome, madam.
Okay, madam. Thank you.
Okay. Now, curricular expectations. See, this is the now confined to that. Yes, madam asked about this. So, mathematician. So, what gives what expectation from this mass modeling? So, ability to think logically. The new situations we think logically. And formulate, we are giving chance to that one to formulate, but generally we do formula, we'll find out. But he himself is formulating and handle abstraction. Any problem is there, then how to handle the abstractions. Okay, and if it's right or not, if formula is correct or not, then also he has the chance of understanding that one. That is called mathematician. So this is very clear that rather than knowledge of procedures, formal and mechanical. So that one, what we are doing so far is much, but here he will himself is exposed to that thinking logically and formulating, and any obstacles are there, he will handle it. And mathematical vocabulary, he will learn the new situations, the borders. Suppose you go to the logistics in the port, a new vocabulary will learn it, because we know only confined to text to some vocabulary only mathematical, but there are many fields are there where we can understand the new vocabulary, that mathematically you will understand the vocabulary. So if you go to the different airport, then there are many factors are there, what you call them, what variable is used, you understand it. So we are giving chance to them to understand it, mathematical vocabulary in different situations, different real situations. Now consolidation and generalization of the concepts. What you have learned the concept, you will consolidate all together and you will generalize it. And so far what he has learned so far, you will generalize it and you understand the situations. So understanding and proving the mathematical statements, whatever statements are there, we will make to understand it. And then for the proof, he will use this method to solve the statements. He will himself understand it. So directly understanding the one way, and he himself making understand one way, because data is given, and from that he formulates, and you understand the one method. Formula is given, and dealing data is one method. So here you will understand, and proving proving the mathematical statements he will do himself. So we are giving chance to them. And addressing problems that come from the other domains, such as science and social science. Not only mathematics problem, that's what madam has mentioned, because known only, not unknown also here. And different subjects also, correlating the other subjects. That is science and social sciences. Okay. So how these are related, what problems are there in science? Many problems are there. As we know that the science creates problems and mathematics solves the problems. And social science also, there are many, like I told you about the population and this item. And health also, we are having many health policies, which they listen, but what is the problem actually they don't know. But this process, we can make them to understand this. This is the real life problem where we are applying the mathematics. So next, integration of concepts and skills that the children have learned in the problem solving ability. So whatever he knows, for example, we have thought about the fish problem. So already they know the skill of that is fraction, find out from the whole part. The simple concept they have used it. And the problem is the second example which we have taken, there we see the interest, simple interest problem. They know already concept it, but they are applying the problem solving ability. And that is they are the different situation, new situation. They apply the math model which is known to them. So that is one thing. And analyzing and constructing the process involved in the mathematical reasoning. So you analyze the problem and you construct the process. You will learn that how to do. Maybe in the school level he is having only confined to this thing, but once he learned about this mass modeling in higher classes, he will himself study and research, and that is expectations from the from this mass modeling. Establish linkage between the mathematics and daily life experiences. Okay, and access to the curriculum. So this is the curriculum expectations. What we are expecting from the students after learning the mathematical modeling. Right. Any doubt? Now I'm telling about the conventional, as we are doing conventional. This is a mass modeling. So what we will do? We'll do learning facts. We'll learn the procedures. If anything is there, we define the things. With theorems, we learn the theorems. And then the results, we'll understand the results. And then we find a solution. This is the things which we are doing. This is conventional method, which we studied also regarded, and which we are teaching also in the same way. So next comes about the what is different way, mass modeling. So we are collecting the data or a situation or a problem, whatever it may be, and then we study, we assume we do assumptions, and then we are constructing the mass model. Sometimes the mass model which are there in textbook may not be there. Sometimes they are different also. So he will study about the mass relationships. The relationships he will study about the factors which are related and how the new formulas also will be created. These logistics and that how things are the space, how they are placing the things. That is the volume, total volume is there, how much volume is used should be there. There are many formulas which he is not knowing also. From the data, then he make a mass model also. And after mass model, then you evaluate will be done. And after evaluation, he establishing is correct or not. You see that. And generalizing and finding patterns. Generalize it is it applicable or not? Is it applicable to any other fields are there? It generally can be applicable to all such problems or not. If any patterns are there, you can find the patterns also. And then after that one, you can do prediction. That is validating. So then from that, sometimes he infer also new things. So this type of skills will be developed by using the mass model. So one more simple problem which we have collecting data. Very simple because we are given that. So it is from the 6th to 8th class. I have taken the problem from that. This is the data of the weekly wages of 30 workers in a factory. Okay, this problem already there, but we'll see this. So now, can you tell me that how this data is organized? Anybody can say that how data is organized? What ways you can organize the data?
We divide them into class intervals and do it, no, sir. Class intervals, program. Frequency distribution table, class intervals,
Frequency distribution table,
sir, by tally marks.
Represent
by using tally.
So we'll take some interval of daily wages.
Yes, 8,284. Lowest 800 to
Corresponding frequency will be yes, ma'am.
lowest 800
800 to 810 to 820 like that, sir.
20.
Yes, right.
Class intervals, class 10, we are taking as 10, sir.
Class interval, tally marks, frequency.
In any other form, we can represent this data.
Any other form?
I think sir left from the meeting.
Histogram, sir.
Yeah.
Histogram. Continuous intervals are there now, sir. We can take class in.
Okay, fine, madam. Any other? Any other? In any other form we can represent?
Using frequency polygon, sir.
Frequency polygon.
Yes, frequency polygon. Frequency polygon.
Frequency polygon. Any other?
Sir, actually,
Sir, we can arrange the data in ascending and descending order.
Pie chart and all these things are representation of data will come on.
sir, all these come under pictorial representation.
Pictorial
Okay,
representation.
fine.
Yes.
Any other?
Pictorial and non-pictorial.
Name any other? My question is that how do you do only pictorial representation you have considered that by making frequency distribution table we can draw histogram, frequency polygon, and other apart from pictorial representation, what can do with this data?
We can arrange them in ascending order, descending order.
Very good.
Yes, sir.
And further
We
what
can
we
use measures of central tendencies, sir.
very good, madam.
Yes.
Any other? We can find median by arranging the numbers in ascending order, or we can find
Yes,
the
sir.
mean also. We can find a mode
Median mode
Yes,
also.
Yes, sir. So
Measures of central tendency we can take it.
yeah. So this is one example. We can make frequency distribution table. Then we can draw the histogram. So my screen is visible, right, sir?
Yes, sir. Yes, sir.
Okay. So now I'm going to develop the digital models. Please, I request all of you to mute your mic. Please. Still noise is coming. Okay. So digital model, already sir told that about the introduction part. Nowadays we are using in our online classes also. So digital modeling is the process of creating a computer model of an object that exactly replicates the form of the object. The plenty of digital models are ready-made digital models are available in the online, so that we can use. So I'm going to show one by one. So let us see the first one, that the website is mathlearningcenter.org. So I will show the website also. This is a website. I will share the link also. So many apps are given and we can use any app. So I'm showing this geoboard first. And we have to click here, open web app. And there are three types of geoboard is given. One is square geoboard, rectangular and circular. Anyone we can use it for the modeling purpose. We can teach the students shape of the different triangle, quadrilateral. I'm giving one demonstration. I'm going to draw one square. Is it visible, Anna?
Yes, sir.
Yes, sir.
Model to teach the different types of maths models, the different types of shapes of triangles, quadrilaterals. Even in yesterday, one teacher used this model for height and distance class 10th also. So that also you can use it. And now let us move towards the another type of digital model. I think this digital model already Purushottam sir explained. mathsisfun.com. So a lot of apps are here in this website is also given, like data, geometry. I will show one app of algebra. So here this app we can use for solving linear equation in one variable. So whenever you will click on this new equation, one new equation will come up, and you can solve by using this plus minus x and plus minus 1. What we used to do, we used to keep a variable on one side and constant on other side. So we have to make it x. So what I have to do, I have to add minus x to both sides. Now I want to remove this plus 1. So minus 1 to both sides. Like that we can solve any equation. So we can take a real life situations based on a single variable. And whenever you will click here, one more equations will come up. I will show one more example. Right. Suppose this is a textbook question, class 9 question. One question is given below are the seats won by different political parties in the polling outcome of a state assembly election. So political party, 6 political parties are given, and the number of seats won is given, and we have to represent this data in bar graph. So how we can use that digital model? So here data is there. We can click on this one, and graphical index, again we have to go through this one. So different types of graphs are given. We have to choose bar graph, and here some numbers are given. So these are the values and these are the labels on the x-axis. So values are 75, 55. So I'm going to type here 75. We have to separate it by putting one comma. 55, comma 37. Next is 29, comma 10. And the last one is 37. Okay, so now I'm going to label all this one. First is A, B, C, D, E, and F. After entering all these values and labels, the bar graph will be generated here. Okay, and I have already typed this polling results, political party for x-axis and y-axis seats one. That is why it appears. Otherwise, we have to change from here. By default, nothing will be there, title will be there, and like that it will be there, and we have to enter here. So this is political results, political party, and seats won. So like that, this model we can use for any daily life examples. So now we'll move towards the another one. We can use some games also. We can use some simulations also. Already you have seen, you have gone through some simulations in yesterday's session. That is Purushottam sir. I think he has shown some simulations of
PHET.
Yes, PHET. So that also I will show one example. So turtle game is there. Turtle game is there. Through that we can teach the students different types, how to make the different types of shapes. And games are there and simulations are there. I will give some one demo of all these different types. So let us move towards turtle game. So one platform is there, Clicks platform. They made so many apps for online platform. So this Turtle Blocks is one of the platform where we can teach the student how to draw the different shapes by using turtle. So I will give one demonstration. So this is a free version. Only 3 movements of turtle is there: forward, left, and right. So we have to drag here. Now I would like to start from here. Suppose I want to make one rectangle. So rectangle, first I would like to make this turtle forward 100 steps. Again, one more. This is, I will keep this as breadth. Now I want length to be drawn. So I want to rotate this turtle to right hand side. 90 degree. So this right turn we can use up to 90 degree angle. Okay, so 1, 2, 3 length, again 90 degree. Now this is 200, so we have to click on forward 2 times only. 1, 2. Now again right turn. Now this is 300, we have to move forward 3 times. 1, 2, 3. So our rectangle is completed. So like that we can make any figure by using this turtle, and this is very good game to teach the student different types of shapes. And now let us move towards one more game part. This is a police squad game. This is also available on Clicks platform. So I will show this also, how to play this game. By using this game, we have to
this one is available. Which platform this one?
Sir, I will share the link, sir. I will share the link in WhatsApp group. So by using this game, the child will recognize the different types of shapes made by line segment. Okay, so how to play this? We have to click on clue first. The culprit has more than 5 straight sides. So this is one clue is given, and we have to identify the not culprit. We have to identify the other person to release from here. So the clue is given that the culprit has more than 5 straight sides. So you have to identify to whom you have to release. So 1, 2, 3, 4. I'm asking the question, you want to release which one by using this clue? Because we have to caught the culprit. More than 5. It should not be more than 5 straight sides.
Sir, we can release
Release fourth one.
Fourth one?
Yes, sir.
Okay, fine. Released. Now, if we select the wrong button, then here one error will come. Okay, fine. Now, then after that, we have to click on clue. Then again, one clue will come. The culprit has exactly 8 straight sides. First one. Now, which one you want to release?
First one.
First one.
Third one can be.
Second release.
Okay, second. Because first one is culprit according to this clue. So we want to release the second or third one. Okay, released. Now there are more than one clue. Okay, fine. So we can release this also, or this one.
Third one we can release.
But this is also exactly.
Third one also has 8 lines.
So actually, this is also exactly 8 straight sides, and this is also exactly
8.
So both are culprits.
Okay.
Your case is unsolved. Are you sure you want to end? Okay, 1 minute. We can. Okay, one more time we can try. The culprit has more than 4 straight sides.
So you can do other than 4.
Release the first one.
First one. First one.
First one released.
Okay. Second one. The culprit has more than 1 equal pairs of sides.
The second one you can release, sir.
Second and fourth release, sir.
Second can be released.
Second.
Yeah.
Second and third.
Third also has.
Third, 4 pairs are there. Okay.
Third also can release.
Next, the culprit has exactly 2 equal pairs of sides.
Third release.
Third we can release. Okay. So after that, done. So fabulous work. You got the culprit. Like that, we can use this game also. And the next one, Let me close this one. Next, this is the platform. This link I will share in the WhatsApp group. And this I have already shown. This also we did. Next is simulation. This I think you did yesterday. I will show one example of area builder. There is one area builder game is also there. Through this, we can teach the concept of area, perimeter, and fraction. So this is level number 6, first question. Our goal is that area should be equal to 45. किसी को mic on है देखो. Madhvi madam,
Sir.
Mute your mic. Bharat sir.
Okay.
So our goal is area should be equals to 45 and perimeter should be equals to 28, such that the light color shaded it should be equals to 1/3 fraction and the dark one 2/3. So 1/3 of 45 means 15 and 2/3 of 45 means 30. So now what arrangement we can do with 45?
Sir, we didn't get you.
Dimension. What dimension we can use by using 45?
9/5.
9/5.
Okay, if we take 9/5, so whether we are getting perimeter 28, because we can do 15/3 also. So first we will check for 9/5 whether we are getting perimeter 28.
Yes, sir.
Okay, so we are getting. So we'll make 9/5 a block by arranging such that the light color we will take a 15. Okay, so we'll start from here. One more. So 9, 15 is over. Now we'll fill up with the dark one. Yesterday in Kolkata region, one teacher asked that how we can use it for slow learner. So that also I will show you. So whether our question is completed, after that we have to click on check. If it is correct, then smiley face will be there. Wrong. So where we went wrong? Sir?
One more row we have to draw, sir.
Yes. One more is left because 9/5 was there. Chalo.
In width we have to take, sir. One more.
Yeah. Then after that we will click. Yes, correct. If it is wrong, it will show a sad face. So for slow learner, you can start with level 1. A very simple area we have to construct 12. So he can take either 6/2, 4/3 or 3/4, whatever it be. And level 2 also we can go with the step by step. When it comes to level 6, then it will be mixed with fraction. Okay. So this is the PHET simulation. Now let us move towards the next topic, pedagogical model. Already sir told about pedagogical model. Pedagogical models are those models which teachers sometimes provide to students so that they better understand some mathematical concepts. For example, this division of integer or integer mol, or physical some models of 3D shapes, and fraction model for multiplications. The pedagogical model describes what effective teachers do in their classrooms to engage students in intellectually challenging work. And it provides an overview of the learning cycle and breaks it down into 5 domains. First one is engage, the second one is explore, and the third one is explain, elaborate, and evaluate. Engage, the teacher know their students well and engage them in building supportive, inclusive, and stimulating learning environments. Teachers motivate and empower students to manage their own learning and develop agency. And the next one, explore. The teachers present challenging tasks to support students in generating and investigating questions, gathering relevant informations, and developing some ideas. They help students expand their perspectives and preconceptions, understanding learning tasks, and prepare to navigate their own learning. And the next one is explain. A teacher explicitly teach relevant knowledge, concepts and skills in multiple ways to connect new and existing knowledge. They monitor student progress in learning and provide structured opportunities for practicing new skills and developing agency. The fourth one is elaborate. Teachers challenge students to move from surface to deep learning, building students' ability to transfer and generalize their learning. They support students to be reflective, questioning, and self-monitoring learners. And the last one is evaluate. Teachers use multiple forms of assessment and feedback to help students improve their learning and develop agency. They monitor students' progress and analyze data to draw conclusions about the effectiveness of their teaching practices, identify areas for improvement, and address student individual needs. So these are the 5 domains of pedagogical model. Now we'll move towards the today's assignment. This is the individual work for every participant. Every participant have to take a problem on real life situations or identify a real world mathematical model or situation like sir told you about COVID-19 problem, and list the assumptions, then read, create, list down, find the data points, analyze and visualize the data point represent. For example, you can represent it by as a graph, make conclusions and future predictions, and after that the last, give the significance or importance of the model. This is the individual work. I will share in WhatsApp group also, and this individual work you have to upload in the link I will provide. This is for Hyderabad region, right? This link I will provide. Every participant has to prepare a simple mathematical model by using the that steps which sir explained, 2 examples, and you have to upload your document from here, and the file size should not be more than 10 MB. It can be in the form of document, it can be in the form of PowerPoint, it can be in the form of PDF, or if you are very interested, you can make some video also, short video, but it should be less than 10 MB. So this link also I will share with you, and in all the regions, all the teachers have shared, and after that I will compile and I will share to all of you. And now let me check whether Satyanarayana sir joined or not. Satyanarayana sir, are you there?
Yes, sir. Just now I joined, sir. I joined.
Okay, fine, sir. Now we'll move towards group work for participants. Will you explain this one, sir? Satyanarayana sir.
Please continue, sir. One little part.
Okay. So now for group work, you have to identify a math topic and you have to model it into real world context using some variations. After that, you have to list the learning outcomes also. So this is one, and the second one, you have to identify a real life problem representing in a mathematical form, observation or data, then list the learning outcomes. Now I will clear about this too. What you can do, this real life problems you can do as an individual work, every participant, and you can select the best one to represent in the group presentation. And for this one, the first one, you can take a digital model also or physical model also to explain the some real life situations. But you have to follow the steps which now sir is going to explain one more example. Sir, will you explain one more example after this?
Sure, sir. Okay, sir. I will do.
So our purpose is that while doing mathematical modeling, you follow the process of modeling. I also agree that we are all following the same thing, but in this workshop we would like to request everyone, whenever if you are going to submit the second individual problem, please submit in the that format, that steps, which now one more example sir is going to explain. Any doubt regarding this model? Any doubt regarding group work? Okay, sir, Satyanarayana sir,
sir.
Yes, you take up this one. One more example. How to write the steps, how to follow the steps, sir will give one more example. So this is a question. Sir, please.
Sir, course director, sir, and coordinator and personal, please excuse me. In middle B2 power cut was just from you all.
Okay, sir, carry on.
And then one more example I'm giving, because you are submitting the work, group work. Then one more example I'm taking here from the heights and distances. So here the problem is here. The angle of elevation of a top of a tower from a point on the ground, which is 450 meters away from the foot of the tower, that is 45 degrees, and to find the height of the tower. So our task is here, finding the height of the tower. So first step is, your print should be like this, with the headings, understanding the problem. So he's understanding the problem, should we explain here. Let h denote the height. It is given that the horizontal distance of the foot of the tower from a particular point O on the ground is 450 meters. If you have a picture, you can use the picture. So you can understand the problem clearly about this. And we have given variables of we have given, and values which is known to us, which is given in the problem, we have given the values. So we also know that the angle of elevation given by theta is 45. So this is the angle of elevation is given to that. And the real problem is to find out a height h of the tower using the known distance d and the angle of elevation.
This is theta.
This is theta, not q. This is theta. Next, sir. Next step is mathematical description and formulation. Mathematical description and formulation. The three quantities mentioned in the problem of height, distance, and angle of elevation. So here we can describe this one. AB denotes the tower. OA gives the horizontal distance from the point O to foot of the tower, and the angle AOB is the angle of elevation. Then what we have? Then we have tan theta is equal to h by d. This is the mathematical model we are using here. Tan theta is equal to h by d. So h is equal to d tan theta. So now we are going to find out the value of the height of the tower. So this is an equation connecting to the theta, h, and the relationship between all these variables. So this is about the mathematical description and formulation. That part is over. Next, solving the mathematical problem. So the equation 1, to solve the h value, you substitute the values which is known to us, and we'll find out the h value. That is the height of the tower. So next, height of the tower. So that's nothing but 450 meters. So this is the solving the mathematical problem. Part is over. Next, interpreting the solution. Solving the solution, what we have found? We have found that we got the height of the tower is 450 meters. Have you reached the solution or not? That we have to ensure that. In step 1, we have studied the real problem and found that the problem involves 3 parameters: height, distance, and the angle of elevation. That means in this step, we have studied the real life problem and identified the parameters. In step 2, what we have done it? We used some geometry and found the problem can be represented geometrically as shown in the figure. Then we used the trigonometric ratio for the tangent functions and found the relation as h is equal to d tan theta. So mass model part also over. So in this step, we formulated the problem mathematically. That means we found an equation representing the real problem. And next, step 3, what we have done it? We solved the mathematical problem and got that the value is height of the tower is 450 meters. That we found the solution of the problem. Solution problem also, that part also over. And last step, what we have done, we interpreted the solution of the problem and stated that the height of the tower is 450 meters. So is correct or not, then we have to see. So interpreting the mathematical solution to the real situation. So this is the steps we have to follow. Well constructed. Okay, thank you. Thank you very much. Sir, continue, sir. Kumar sir.
Sir. Any doubt in this group work? Let us know. I will share the PowerPoint also in the group. I will share the all the links of that digital models which I have shown you. That also I will share. And anything else want to share?
So, what is the difference between the individual work and the group work?
Madam, individual work every participant has to have to do and submit. And while doing group discussion in your group meeting, how you are doing through Google Meet?
We have found WhatsApp group and then we do the Google Meet also. Like
So
in mathematical modeling, how it is different in both? In individual, what kind of mathematical modeling we are doing, and in group task, what kind of mathematical modeling?
That I'm explaining, madam.
Technical difference.
Work every teacher has to do, and out of those individual work that is related with real life situation, you can present in group presentation. Okay, and the next part is that using any model, either digital model or physical model, you can present the direct group presentation. You can select any one participants from your group, and you can have the group presentation in the evening. That means one group have to present two. One is individual work, best individual work, and another is this model work. Still confusion?
Sir, Kumar sir, small. That means in individual work, we need not to do the graphical representation, or we need not to use these platforms which you had shown.
You can use it, madam. You can use it, and you can write it also in that one. That is up to you.
Okay. Okay.
So you will not be able to show all these, and you can take a snapshot of what you did in digital mode.
So whatever we are doing individually has to be represented in that Google form which we will be sharing.
You have to upload, madam. You have to upload that. The compiled one I will submit to course director.
Sir,
Yeah. Okay.
Question, sir.
Yes, madam.
Sir, normally every year for schools, some circulars will come regarding to keep maths modelings. But many of us, maths modeling means we go for keeping some sort of models, maybe working or stable ones. Okay, here from today's class, what I came to know is in maths modeling, we have to choose particularly only one problem, real life related some problem we have to take, and we have to go for solving. In maths modeling, only we have to stick to only one problem. Is it not?
Madam, can you repeat your question, madam? Because your voice was not able. We are not able to hear.
Sir,
increase the volume.
Maths modeling.
Yeah.
We have to stick our ideas, or we have to take only one situation and we have to go for doing it. No, only one problem, one situation only will be there.
Yes, madam. Yes. Any one situation, in any one real life situation, you can take and you can do the maths modeling.
So then why every time I have seen whenever circular comes regarding the maths exhibition and all, maths modelings go for keeping, means many of us we go for keeping only exhibits or some sort of models to explain some concepts.
Madam, see, we are using mathematical models for doing mathematical modeling. That two are very different concepts, because children are using exhibits to explain the real life situation.
Sir, in maths models, they are not doing any sort of modelings. In the modelings, we need to solve and we have to interpret something. But whereas in models, we are just concepts alone, we are explaining to maximum extent, only concepts.
That's why they're not going to national level, madam.
What you are saying?
That's why maths model, they don't go to national level.
Madam, actually, they have to make a model and they have to correlate with the real life situation. It is not necessary that they have to give example and they have to solve the questions. They can correlate with the real life situation and they can explain their exhibits.
One more last question, sir.
Yes, madam.
I think it is not required for every modeling to make graphs. Can be any sort of
Yes.
No, not required.
Not required, madam.
There are many parameters where you can do.
Not
Even we can see, madam. Even we can construct a frequency distribution table, and we can find the mean also.
No, sir. Not necessary to have only that. What is that? Mean modes related and graphs related. Can be any manner. Like sir, just now he said about the tower question. That is trigonometry question. In that question, nothing is there. No.
What, madam? Tower question?
Just now Satyana sir, he said he explained one question related to the trigonometry, applications of trigonometry. In that, no statistical data analysis or graphical representation or frequency distribution, all these things are not there.
Even in simple interest question, it was not there.
That is what for each question in unique manner. We are
No need that it is always based on graphs only.
Okay.
But thing is that it should be connected with real life situation. Any more doubts? Because already it is 11:41. We have to attend one more meeting at 2:30.
Sir, then mathematical reasoning and please distinguish mathematical reasoning and mathematical modeling.
Sir, can we say this is the design of mathematical model? Design of mathematical model is correct suitable word for this. Mathematical, as madam said, mathematical model is that we are presenting geogra, that is in solid shapes maybe, and this is the design of mathematical model which is applicable for daily life situations. For example, as sir said that first fish pond problem, that can be applicable for the coronavirus, how it will spread. For example, when the foreigner is coming to the airport, they are making stamp and that person will be going to society, and he may contact, for example, 200 persons. In that village, maybe 10,000 persons are there. What is the probability to get the spread of the virus in that village? So,
okay. Yes, sir.
So this is, you can say, is a correct word for design of mathematical model. In the same way, if EMI problems are there, EMI, for example, in our daily life situation, EMI formula is a standard formula, maybe, I don't know exactly. So when you purchase any object, anything in the market, how to make the EMI. So that EMI will be make a standard formula for each and everything where we are going, where we are paying the installments. So that is one of the model. Is it correct, sir?
You can use it, sir. You can connect it with that real world problem.
Sir, thank you.
Sir, it is correct, sir. It is correct.
But model is different from modeling, no.
Design of mathematical model.
Mathematical, yes, sir.
No, not model, sir. It will come under modeling. How you can pay, what is the interest, and if you make how to design to solve that problem. That is, it will come under modeling. If I am not wrong.
So interest is the concept, that is the mass model you are using interest formula. But what is situation you are taking? But in situation you are taking, that the situation you are solving by using the that you call the interest mass model, you are solving that. So that is what is situation you are just now I told about the that is a simple interest problem. Here he has to wait. The situation is a different than demand situation. The real situation where he has to wait for to purchase the washing machine. So you can use it as a mass model. You can use it.
Sir, actually, sir, all formulas are mass modeling.
Yes,
I think so.
Sir,
formulas are not mass modeling.
You have to, why, sir? Why, sir?
Situation. Mass models only.
Why, sir? You come to a conclusion. Your test.
Now we are
Sir,
using words like math modeling, all these things, sir, but well-known words are verbal problems, application problems, okay, daily life situations. We were using these words, okay. These problems we frame, okay, then afterwards we read, and later on we go for simplifying. Those only with different vocabulary they are putting up in statements. That's all is the thing, sir. No difference is there. Already we
not much difference.
know the application questions and all. I feel that. Is it not, sir? Kumar, sir? Application only, no?
Yes,
sir, when we are trying I is equal to PTR by 100, why is it not a model, sir? We are testing for 1 year, 2 years, 3 years. Finally, we have come to I is equal to PTR by 100.
Sir, it is a mass model only. We use mass
Yes.
model. We use it. That mass model is processed in also to solve the problem. Then the whole thing is called mass modeling. The relationship is called mass model. That's it.
Could be, sir.
One at a time. Please, one at a time.
Model means, sir, are you able to hear?
Yes, madam.
Modeling means a
Advice
physical object, some sort of piece, I feel. Modeling is a way of doing this.
Yes. Yes, madam.
Kumar sir.
Solving steps are where steps are involved to solve the problem.
Satran
I don't have mass model relation between among the variables and formula. So that if you apply this one to real situation and process we follow, this is called mass model. And mass models can be different types of models are there. We have seen that Sarah explained. The digital models also. If you take digital model, we are showing about only mass model you are showing there. Model you are showing there. You are not solving any real problem. If you take a real problem and you are using the mass model, you are solving the real problem situation. So I think they are clear about this mass models and modeling. Modeling the process solved by using the mass model. Okay, I think clear. Any doubts?
Sir, is there any difference between PISA questions and mathematical modeling?
PISA questions, yes or no? No, I think they are also mass modeling only because we have seen solve problems. We also we will use the math model to solve the problems. PISA questions are real life problems, sir. Yeah. But while presenting in a group, you follow the steps so you can understand it step by step. If you remove the steps, it will be PISA question only. Okay, PISA solve question only. So please use that one. And group already told about this one. Every group will present one model and one modeling. So
linear programming also comes under mathematical modeling only.
Yes, madam.
Linear programming.
Linear programming, but we are not going that extent. We are going to level is
higher level.
Yes,
Just a query, sir.
Yes, madam. The linear program is widely applicable in the airports. Minimize and maximize values. It is that part of the mathematics used there only. Okay, that is the real life problem only. You can take it, madam. You can use it also. You please that different types of problems we come across. Then we also exposed to that different part of the place where this mass modeling is applicable. You can take for mass modeling. Please go out of textbook. Don't use textbooks. So out of textbook, we go and find out.
Sir, speak quickly, sir, because we have to attend the TCT mentor staff meeting of KVs in Telangana so that we can finalize the dates of 21 or 22. Please be quick. We have to attend one more meeting.
So when we are going to the real life situation like testing and all, everybody has the unique experience. Like how will you assist? Because if I change this, I could not catch a fish.
Madam, we are not experiencing, we are not taking only a merely experience, we are exposing to the situation.
Yes.
We are exposing the situation. We are making the others to expose. Now we are going to present now in group discussion. All we are exposed to situation. We didn't get any experience there, but we will expose to situation. I think in a group presentation we will do that. All we expose the new situation because if you take a different types of situations or different fields, then we'll be exposed to that. And that we don't have any experience, but we'll expose to that. Right, madam? Any other?
Any other? Almost 11:49.
Sir, Brahmaya sir. Brahmaya sir.
Oh, sir.
Sir.
Yes, sir. Yes, sir. Thank you, sir. Thank you very much for your wonderful presentation. So participants are requested to do the tasks as well as given in the training program, and in the evening class, in the evening session, you have to present.